Question number 15 involves momentum, and from the VCAA formula sheet, momentum equals velocity times mass. So I've got a momentum of 20 is velocity times a mass of 9. So when t equals 0, the velocity is 20 on 9, and when t equals 8, the velocity is minus 10 on 9. So this thing starts in this direction and finishes travelling in this direction. Therefore, the total distance travelled is this distance plus this distance. So what I can't do at this point is to say that S equals ut plus a half at squared, because that's just going to give you the distance between where you start and where you finish, because this is displacement. It's going to tell you where it is at a particular time. So I can use the fact that acceleration is v2 minus v1 over t2 minus t1, which means I've got minus 10 on 9 minus 20 on 9 over 8, which is minus 30 on 9 times 1/8, which is minus 10 on 3 times 1/8, which is minus 5 on 12. So acceleration is minus 5/12. What I'd like to do is to find out when does it turn around. So I know that u equals 20 on 9. This is when velocity is 0 and acceleration is minus 5/12. I know that acceleration is constant, so I know it's going to be negative 5/12 all of the time. So I could use v equals u plus at to find out when the velocity is 0, 20 on 9 minus 5 on 12t, t equals 16 on 3. So I'm going to use a velocity time curve. I know we start at 20 on 9 going in the positive direction, and we finish at minus 10 on 9 in the negative direction. And I know that all up that's 8, and I know that's 16 on 3. And what I'd like to do is I'd like to find the distance travelled in the positive direction, the distance travelled in the negative direction, and add them together. Now I'm going to do this because these are two nice triangles. I know that this area is a half base, which is 16 on 3, times height, which is 20 on 9, plus this area here, which is a half. The base will be 8 minus 16 on 3, 24 on 3 minus 16 on 3, that's 8/3. So 8/3 times 10/9, and put that on the calculator, and that should give me the total distance travelled, which gives me 227, which is answer C. So momentum formula, I then created a velocity time curve because the area under the curve is distance travelled. I could have done two separate distance equations using these, with S equals ut plus a half at squared, find that distance, and then coming backwards with u equals 0, I could have done the second bit once I knew the time. Both of them would give the same answer.